Hello. Today I'm just going to give you a quick refresher on different classes of functions and their names. So to start this out, I want to start with the constant function. Constant function means y equals a number that's not changing. So y equals 1 is a number that's not changing, which means if I'm graphing this and I make a table, an xy table, every single y has to be that same exact number, no matter what x is. If x is 1, x is 2, x is 3, all these points, 1, 2, create your constant function. And so your constant function is always a horizontal line. Now, a direct variation is y equals kx, so your graph is a y equals a number, x, which is a linear. But one thing direct variation's not going to have is it's not going to have any add or subtract after that equation, which means your y-intercept will always be 0, 0. So direct variation always goes through 0, 0. Now, the slope can be anything it wants. The slope can be 2. The slope could be 5. The slope could be 1/3. It doesn't matter. But a direct variation always goes through 0, 0. And it's a linear equation. The identity function is a specific formula. It is y equals x. That's it. So your slope will always be 1, and it'll always go through the origin. So the identity function is a direct variation function, but it's more specific where your slope has to be a 1. So it's still a line, it's still linear. Y equals 1x plus 0 is it. The slope will not change, so they call it the identity function because the y will be the same number as whatever your x is. So if I made a table over here, it would look like this. If x was 1, y would have to be 1. If x was 2, y has to be 2. If x is 3, y has to be a 3, so on and so forth. So that is the identity function. Next, we talked about greatest integer functions. These were also known as step functions. And the step functions, you can see the steps. They look like steps. In other words, the greatest integer function cuts off the decimals, and so y will not go up in parts the way x does. So if x is 1.5, the greatest integer function cuts off the 0.5, and the y will just be 1. So if you go over 1.5, you will still be up 1. And that's what creates these flat horizontal lines. And as soon as you get to the next integer, that's when it jumps up to the next one, creating the next step. So greatest integer function, aka step functions. Absolute value functions, I like to focus on the v on this one, absolute values, because absolute value functions graphs look like v's. Now, this absolute value can be moved around. It can have different slopes. It does not have to be through the origin, but your x is always inside absolute values. So absolute value equation, remember that v, your graph will look like a v. Quadratic equations. Quadratic makes your parabolas. So your parabolas can be this U shape, or it could be upside down like the arch. But quadratic functions look like y equals x squared. Now you can have more x's after that, you can have numbers after that, but it has to be a y equals x squared is your highest degree. Square root functions are the inverse of those quadratics, so you still get kind of that similar curve, but to keep it a function, you're only going to have one side. You're only going to get the positive values of those, unless they put a negative side on the outside. So you're only getting half of that U shape tipped on its side. And so remember, the vertex of a quadratic is the starting point of our square root function. Rational functions, Remember, what makes it rational? It has an x on the bottom. It has an x in the denominator, which means there's going to be some value that just x cannot be, creating either an asymptote or a point of discontinuity. And so if x is on the bottom, there is a value that x cannot be, otherwise you'll end up dividing by 0 when you solve it. So that is a rational function. Now, a more specific rational function is the inverse variation, and an inverse variation has no add or subtract in it. It is just a value over plain old x. So that means your asymptote will always be your axes. So that is 9 different classes of functions. If you need to replay this video or go back and look at it, feel free, jump ahead, jump wherever you need to, but these are some of the classes of functions we've graphed so far. Thanks. Have a great day.